If you remember, it was we learned that 1 mole of something equals 6.02 times 10 to the 23rd particles. This number here is called Avogadro's number. It was named after Avogadro. And primarily because Avogadro was doing a lot of experiments with the amount of particles in gases. He was interested in experimenting with different gases. And Avogadro said that if you take 2 equal volumes, so let's make like 2 boxes here that are exactly the same. Might not look the same, but let's say they're equal volumes. Equal volumes. And of course, if they're in the same room, they would be under the exact same conditions, which means there's temperature, and of course there's pressure. And we'll talk a lot more about these when we get to gas laws, but if they're in the same room, then you have equal volumes, equal boxes, and if they're under the exact same temperature and they're under the exact same pressure, what Avogadro said is that they will have the exact same amount of moles of gas in each of these. Moles is usually given by the letter N. So if we figured out how many moles are in this box, and 1, and we figured out how many moles are in this box, and 2, if they have equal volumes of space and they're under the same temperature and same pressure, then equal volumes of gas means equal amount of moles. Now you might not think that's too amazing, but what he's saying is it doesn't matter what kind of gas is in this box. Yeah, that's a little more amazing, right? So for instance, if in this box here you have helium atoms floating around in here like this, these are monatomic atoms floating around in here, and in maybe this other box you have oxygen atoms, which of course are diatomic. Oxygen, I guess I should have said oxygen molecules, sorry. They're diatomic. Okay? And if they're under the same temperature and same pressure, both gases are under the same temperature and same pressure, and I have equal volumes, it does not matter what kind of gas these are. I will have however many moles of helium gas I have in this box, I will have the same number of oxygen moles in this box over here. So that's what Avogadro determined. He figured out that if you have equal volumes under the same conditions, you will have an equal amount of moles of gas, no matter what kinds of gases there are in there. Or even if the gases are mixed up. I mean, maybe I have some hydrogen gas in here also. Well, if I have 7 moles of all kinds of gases in here, so 6.02 times 10 to the 23rd gas particles, no matter what kind they are here, I would have the exact same amount of moles of gas in the other box, in the other volume. So that's kind of what Avogadro said. Now we take that a little bit farther, a little bit later, and we start thinking, okay, so under what temperature and pressure conditions, you know, if will I have 1 mole in a box, and what will that volume be? So what we have determined is that if you keep the temperature at 0 degrees Celsius, temperature at 0 degrees Celsius, okay, which would also be 273 Kelvin, by the way, and you keep the pressure at 1 atmosphere, 1 atm, 1 atmosphere. This is by the way called STP, standard temperature and pressure. Standard temperature and pressure. standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. So we find out later that if we have a gas that is at STP, then 1 mole of any gas, no matter what kind of gas it is, at STP conditions, 1 mole of helium gas, 1 mole of oxygen gas, 1 mole of hydrogen gas, doesn't matter what kind of gas it is, at STP conditions, 1 mole of any gas will fit into 22.4 liters. That's the magic number. That is what we call the molar volume of gases. The molar volume of gases. If I'm at STP conditions, you will be able to fit 1 mole of any gas into 22.4 liters. Now keep in mind, there's nothing overly magic about this. In fact, if I change the temperature, I change the pressure, then 1 mole of gas will fit into a different kind of volume. But at what we call standard temperature and pressure conditions, 1 mole of gas, whether it's hydrogen or helium or oxygen or anything, will fit into 22.4 liters of volume. That is what we call the molar volume of gases. That'll be an important thing to use for a conversion factor. You'll be able to write 1 mole equals 22.4 liters. Now, of course, you'll only be able to do that for gases, not liquids and solids, only for gases, and only if the conditions are standard temperature and pressure. Hope that makes a little bit of sense.